So the next one is f of x equals 2x over x plus 2 times x minus 5. So again, we start to look for asymptotes. Vertical asymptote, it says x plus 2 and x minus 5 are both in the denominator. So to find the vertical asymptote, we would set both of those equal to 0. And since we're setting both of those equal to 0, that means we actually have two vertical asymptotes. We have vertical asymptotes at x equals negative 2 and x equals positive 5. So I will draw in the vertical asymptote at x equals negative 2 and the one located at x equals 5. For the horizontal asymptote, we have a first degree expression in the numerator, but what is the degree of the expression in the denominator? Well, if you were to multiply that out, you would get x squared minus 3x minus 10, which means it is a second degree polynomial. So therefore, we have a polynomial expression, or excuse me, an irrational expression where the polynomial in the numerator is less than that of the denominator. And according to the previous rule we had, when that occurs, the horizontal asymptote is located at the x-axis, also known as the line y equals 0. So right through here. So now we've got our asymptotes, so let's go ahead and do our t-chart. And we do have two asymptotes. That means we're going to have a very extensive t-chart because we do have points on the left side of the asymptotes, the right side of the asymptotes, and in between the asymptotes. So I'm going to start out by doing the points that are in between the asymptotes. So that would be negative 1, 0, 1, 2, 3, and 4. That would be a good place to start. That will get us on the right side of the left asymptote and close to the left side of the right asymptote. So then we would have to plug those numbers in. So that would give us 2 times negative 1 over, and then the first set of parentheses, it would be negative 1 plus 2. And then the second set of parentheses would be negative 1 minus 5. So in the numerator, that would be 2 times negative 1, which is negative 2. In the denominator, it would be negative 1 plus 2, which is 1, times negative 1 minus 5, which is negative 6. And that would be negative 2 over negative 6, which would equal positive 1/3. And then we would do it in that same order of operations for the rest of the numbers by multiplying the numerator times whatever value I plug in for x, replacing the numbers in the denominator with that same value, do what's in the parentheses first, multiply those parentheses together, and then divide the numerator by the denominator. And when we do all that, this is what the rest of the t-chart looks like. And here you go with that. So when I graph those, negative 1, negative 1/3. That's the left one up just slightly 1/3. 0, 0. 1, negative 1/6. It's about right here. 2, negative 1/3. It's about right here. 3, negative 3/5. A little bit less than that. 4, negative 1. So you can see those 4 points right here, which really doesn't tell us a whole lot about what's going on between the asymptotes. But one point I want to point out is particularly this point here located at 0, 0. That is confusing to some students because they have always been told that a graph cannot touch an asymptote. And that definition is only partially true. A graph shouldn't touch an asymptote as it approaches infinity, in other words, as it approaches the far right and left portions of the graph and the far upper and lower portions of the graph. However, this is the first time you have seen multiple asymptotes, at least most likely the first time you've ever seen multiple asymptotes. So between asymptotes, we are not approaching infinity on the left or the right-hand side. We are between the asymptotes, which means it can cross in an asymptote, a horizontal asymptote. Now, you won't see it crossing a vertical asymptote doing that, because if it crosses the vertical asymptote, then the denominator is going to equal 0. But it can cross a horizontal asymptote. And if the asymptote is located on the x-axis, I've already shown over here that x can definitely be 0, because when x is 0, the denominator is not 0, but the numerator is. So remember, the actual definition of an asymptote is that it will not cross it, it will approach it, but not cross it as it reaches infinity. Going back to the rest of this graph, we really don't have a whole lot to tell about what's going on between the asymptotes. We don't know if it's increasing or decreasing as it approaches the asymptotes. So we are going to have to get some extra points in here that is in between the asymptotes but close to the asymptotes. So on the left asymptote, I think we should use something like negative 1.5 and negative 1.75. And on the right asymptote, I think we should use 4.5 and 4.75. So those are values that are to the left of the right asymptote. So by plugging those numbers into our expression, so for, let's say, the 4.5, that would be 4.5, 4.5, and 4.5. So 2 times 4.5 is 9 over 4.5 plus 2 is 6.5. And 4.5 minus 0.5, or minus 5, is negative 0.5. So that would give us 9 over negative 3.25, and 9 divided by negative 3.25 is approximately equal to negative 2.77. And then we will do that with the rest of those points that we chose, and then the rest of those points would look like this. And now you see those values. So let's graph the rest of those points. So negative 1.5.92 would be about right here. Negative 1.752.07 would be approximately right here. So you can see it's starting to curl up to the left on that side, and then 4.5, negative 2.75 would be approximately here. And then 4.75, negative 5.63, we can see now it is very rapidly curving down that direction. So in between the asymptotes is looking like this. But we still have outside of the asymptotes. So outside of the asymptotes, we're still going to have to pick some points on the right side and the left side. So I'm going to erase everything that we have on this T-chart. And then if we pick values to the left side of the left asymptote, let's go with negative 3, negative 4, and negative 5. And on the right side of the right asymptote, that could be 6, 7, and 8. So again, we'll plug those numbers in for x. So that could be 2 times negative 3 over negative 3 plus 2 times negative 3 minus 5. So that would be negative 6 over negative 1 times negative 8, which would be negative 6 over positive 8, and that is negative 3/4. And then when we do the rest of the numbers in the T-chart, this is what we get. And then you can see what those values are. So negative 3, negative 3/4, that would be left 3 down 3/4 of a unit. And then negative 4, negative 4/9, it's a little above negative 1/2. Negative 5, negative 1/3. And for good measure, if we throw in a number that is a little bit closer to the left asymptote, let's say negative 2.5. So when you plug in negative 2.5, you get negative 1.3 repeating. So when I graph negative 2.5, negative 1.3 repeating, you can see that it is starting to drop at that point. So I think it's a pretty safe bet that the left side is going to look like this. More or less, should be much more straighter than that. And then we can graph 6 3/2, 7 7/9, which is a little bit below 1, and then 8 8/15. 8/15 is almost a half. So then right of the right asymptote will look like this. It's not going to have that little bow in there, but kind of hard to draw. So as you can see, with multiple vertical asymptotes, a horizontal asymptote, and what amounts to a exponent of 2 in the denominator after you multiply that out, you do get a fairly complicated rational function.